Alright, let's see what we got today. And I promised I'd keep streaming until Google responded to me. It's been, I think, over a month at this point. And I got a response back yesterday after following up. And they said there's still no updates regarding team matching me. So it looks like I'm here for a while. But yeah, I mean, the only thing to do is to I guess, keep streaming for now. Let's see what we've got today. Hopefully, I keep wanting easy questions because I don't want to think too hard, but sometimes I think I like the palindromic subtree question we had last time. That one really made me think. Okay, I need to find questions for the mock interviews we're hosting tomorrow. High frequency. Given a list of integers nums, find the most frequently occurring element and return the number of occurrences of that element. So this one, there is probably a way to do it in OF1 space, but that doesn't really matter because we can do a hash map plus just iterate, keep track of max. Yeah, taking it slower often helps. Okay, let's see. So what we're going to do is iterate and keep track of the max value that we have. So as we go through the array, we're going to add every element to the map, and then we can see if that number is more than the current maximum that we have saved. If it is, we update it. Otherwise, we just move on. Okay, so let's go ahead and set up that hash map. I'm going to set up the map of integers. Cool. Hey, good to see you, man. Welcome. Okay. Okay, we're going to set up the map and we're going to iterate and we're going to put everything into the map. Int I in nums. We don't really care about the numbers index, so we can use a for each loop. And then from there, what we're going to go ahead and do is keep track of the max. And we're going to say map.put I map.getter default I 0, and we're going to increment that by 1. And then the second thing we're going to do, yeah, no stream yesterday. I got caught up in paperwork. There's a lot of paperwork to do transitioning from sort of university life to an adult life, and I've been neglecting doing that paperwork for a few days, so I just sat down and pretty much spent the entire day doing paperwork. Much rather have streamed late code, I'm not gonna lie, but you gotta do what you gotta do sometimes. We're going to set max equal to the maximum. Because map accessing is in constant time, it makes it very simple to do this. Map.get I. And that really quickly allows us to update our max as we go, saving us having to do a second iteration through all the keys in the map to get all the values, to get the max value. And by returning max, unless there's a compilation error, I think that should be a good solution. Easy. I'm curious to see if okay. So check power of 2. Given an integer n greater than or equal to 0, return whether it is a power of 2. So This problem, I think, has a fairly interesting trick to it, right? It could seem daunting at first, but given the fact that we're checking to see if the integer, right? We note that it's an integer, and it is greater than or equal to 0. Return whether it's a power of 2. If we think about how a integer is represented under the hood, if I'm not mistaken, it is represented as a 32-bit, what's it called? 32-bit value. And we look at our constraints and see that we're going from 0 to 2 to the 31st. What this means is that there's only a set amount of these things that we can check, which I think makes this problem in constant time because there are only a set amount of powers of 2. There's only a set amount of powers of 2 that we can do. And I think checking every single power is a bit brute forcey, but we can still do it. Because if you think about it, right, I think there's only 32 of them because it goes 2, 4, 2 times 2 is 4, then 2 cubed. And we keep going up until we're done, pretty much. So what we can do is say for integer, for int I equals 0, I less than, let's say 32, I plus plus. And we're straight up just gonna check. If n is equal to math.pow for power of 2 raised to the power of I, we're going to return true. Otherwise, we return, not otherwise. Down here, we're going to return false, because this means that no powers are found. And I think that should be a solution. I wonder, there has to be like is this a math problem here? Oh, bit manip. So for bit manipulation, we can check to see if it's a power of 2 by counting the number of 1s. Because if it's a power of 2, there will only be a single 1 in the entire bit representation of the number. So let's go ahead and implement that solution using the bit manipulation. Let's go ahead and close off this here, remove this here. So we're going to utilize bit manipulation for this one. The way we're going to do this is, if it is a power of 2, there will only be one non-zero in bit representation. Alright, so given that there will only be one non-zero kind of value in the bit representation, what we can do is say while n is greater than 0, we can keep track of a 1 count is equal to 0. I don't think 0 counts as a power of 2 because 2 to the 0 is still 1. But what we can say is if, and okay. Yeah, bit manipulation's pretty neat. Okay. What was it? Okay, so yeah. If n and 1 equals to 1, I think, I'm not super familiar with bit manipulation. Then we can do 1 count plus plus. Syntax. Not too familiar with the bit manipulation. And then what we can do is say, we should bit shift n to the right by 1. N equals n bit shifted to the right by 1. We're going to return 1 count equals to 1. That's the only case when it's a power of 2. Ah, crap. Okay, Java bit manipulation. Let's look this up because I want to be better at this than I currently am. I need a bitwise AND is what I need. One and 0 yields to 0. 0 and 1 yields 0. 0 and 0 yields 0. That's okay. But why doesn't this work? Last bit is 1. Why does that not work? Why doesn't this work? This should just work, I think. See what they have. Oh, is it because I don't have parentheses, maybe? Wow, so it was parentheses. Is the bit manipulation solution slower? Because it definitely looks like it's slower. That's really weird. I'm not sure. And mod 2. I'm not sure which part of this ends up being slower, honestly. Yeah, I mean, guess that works as well. I'm not even sure why. Alright. N and n mod 1 equals 0. I mean, is that any faster, really? I mean, it should be the same speed as doing... Because this bit shift, we only ever, at most, need to do 32 times, so it should still be constant. Yeah, so n minus n and n minus 1 equals 0. Oh, so that way you're basically checking to see if that last number is 0, because let's say you had something like this, 1 0 1 0 0 1, and when you subtract 1 you would get that, and you want this to be false, and that's how that comparison works. Yeah, I mean, I feel like it does the same thing at the end of the day here. Okay. Okay, length of longest balanced subsequence given an S. Return the length of the longest balanced subsequence of balanced brackets. Oh goodness. So, subsequence is delete sum or 0 from B without. I guess, I mean, is this dynamic programming? It's not dynamic. Okay, so my best guess on how to approach this problem. Looking at the fact that it's a subsequence, I think what we do is we take a kind of greedy-esque approach to it where we iterate through. If it's open, we put it on, because keep in mind, we don't really care about the indices of the subsequence, we only care about the size of the subsequence. So what I think we need to do, we put it on if it's open. If it is closed, if it is closed and adding it does not make it unbalanced, we add, and we add to count. If it makes it unbalanced, we just skip it. Because we don't care, again, about where it is. We just care as long as balanced substring. Yeah. Yeah, I had to double check to know that as well. Okay. So, what we're going to do is, I think, just probably do that. So let's go ahead and try that. So we're going to make a stack of string. Actually, yeah, screw it. We'll make it a string. It's a bit more space intensive than character. Actually, no. Let's make it a character. Character stack equals new stack. Cool. What we're going to do now is say for int I equals 0. Actually, we can just do char c in s.toCharArray. Avoid having to index things since this gives us the correct order, and we don't really care about that index. So let's do int length equals 0, and we're going to do a couple things. If c is equal to a unbalanced, if c is equal to an open parenthesis, we're going to do stack.push a open parenthesis. Granted, we don't actually need to keep track of what will be on the stack. It's just going to be, it's going to be these brackets. I think we could avoid it. Yeah, that's what I was going to say as well, as like a space removing space complexity. Let's just do int stack equals 0 for now. And rather than doing a stack.push, we're going to do stack++. This just, it's a habit with like the mixed balanced parentheses where you have like your square, curly, and regular parentheses. Okay, so otherwise, this is closing. So, if stack is greater than 0, then what we need to do is do stack minus minus, and because we closed off two things, we can do length plus equals 2. I think, honestly, that should just be it. Because when we put something on the stack, it doesn't become balanced until we find its matching pair. My result was 6. There you go. I don't know why I had that one there. Perfect. Yeah, there's a good catch regarding the fact that stack was not really necessary. We could just use an integer to count that. Cool, and it's a very fast solution as well. Yeah, thank you. It's it's one of those things where the idea of a subsequence is very scary because it immediately makes you think of dynamic programming. But what's it called? If you can avoid using DP, then it's fine. Because the intuition here is what I think is the hardest part. Honestly, I really like this question. I'm going to save it. We're running mock interviews with our coding club tomorrow, and I think I currently have 2 people scheduled for my sessions, and I'm trying to find very interesting questions. I hope that none of the people who I am going to be leading the interviews for are watching now, because I gave away the solution. But this question is very interesting because it's an intuition question more than anything, because it's super simple to solve once you understand what exactly it is that you're looking for. Let's see what we got on the last one here. Sum of digit paths in a tree. So you're given a binary tree root with each node containing single digits from 0 to 9. Each path from the root to the leaf represents a number with its digits in order. Return the sum of numbers represented by all paths in the tree. Sorry, what? Okay. Okay, so this is going to be 12 plus 13. Uh-huh. Okay. This is an interesting one because it's stored. Okay, so it's stored as an integer. The super sort of trivial way that's like super intensive in both space, I think, and just poor practices, is to keep a. It might be the way that I solved it first here. So we're going to keep a global variable up top. Make helper method to do a, I think, pre-order traversal, where we pretty much go down all the way, and every time we pass in the curnum string plus value of the current node. And we keep, yeah, don't come from my global variables, man. They make recursion so much easier. Yeah, without stack, how would you know? I guess because, I mean, it's one of those things where for this question you don't need a stack, but for example, if this was like longest subsequence of matching like mixed braces, where if we were working with like this, I think that would be where we'd need it. But if it's just one thing, okay, fine. I can avoid global variables. I'll just explain how we do it with global variables. So we pass in the curnum value, and anytime we get to when we get to leaf node, we need to parse out the integer and add it to global total. So for example, here we'd pass in 2, then we'd pass in 2, 5, we'd get to the leaf node and we'd have 2, 5. Then let's say for the right side, oh, that's a 3, not a 2. My goodness. Okay. So for example, we'd have 3. It's very good to identify things that matter versus don't matter in the interview. I think that's going to be one of the reasons I decide to use this question, because if the interviewee, I think the term is, can solve it with a stack, and then, you know, I have the grounds to ask the question, hey, you know, is there anything in this question that you think you could replace to save another time or space complexity? But that's a very good call. Because, yeah, I mean, you'd do 3, then 3, 2, then 3, 2, 1. You'd sum that in. 3, 2, 4. You'd realize you're at a leaf. You'd parse that. But I think I'm going to have to, just for your sake, Max, I'll do it. Like, position doesn't matter is a very important remark. Shows the interviewer you understand the task. I'm assuming you mean position for this one, like position of the bracket, because we don't care about like the index or anything like that. We just care about the count. Great. So for this one, what I think the how about DFS with some math? Yeah, we don't need the global variable. And lots of first-time viewers in Clan Scorpio, welcome, and SDKJS, welcome. Yeah, that's why I've been made fun of. I've been made fun of for my global variables. So DFS plus math, right? Here we know. I think what we can do is pretty much just the DFS. However, what I think I need to do is I'm still going to need a helper method. Public int. Let's do traverse, because we need to pass in a node root, and we need to pass in. Do we need to pass? Yeah, we need to pass in a depth. That's, I think, really all we're gonna need to solve this, because what we can do is a very simple int per node val. Okay, first of all, if node equals null, obviously, to get rid of this, we're gonna return a 0. Then, what we can do then is know the value of the current node is going to be equal to int per node val. This can be, I'll rewrite this into like a more condensed sense. Right now I just want to write it out in a more kind of readable way. Current node val is equal to root.val plus, not plus, rather times power of 10 to the power of depth. So for depth 0, 10 to the 0 is 1, giving us a 1. Depth here, it's going to be 2 times 10 to the power of 1, which is just 10, so which is 20, and it's going to give us a value of 21 for this node. Then what we can do is do int left equals traverse root.left with a depth plus plus. Not plus plus, plus 1. I've made this mistake before where I've done plus plus, and none of my stuff worked because my depth value was off all over the place. So then we can do right. Should it be 12, not 21? Ah, crap, you're right. That makes it a little bit more... Wait a minute. Okay, no, yeah, that makes it a bit more challenging. Just because you need to know your, I guess, max depth for this. Huh. Wait. Wait a minute. How... Wait, how does it make it easier if it needs to be 12? Because we don't know the depth. So we have... This should be... Because the tree isn't balanced. Not all the nodes are on the same level. So here we should be adding 324, 321, and 35, I think. So this needs to be done bottom up then? Is that what it is? I would use a helper method and at last reverse it. I know it would be silly, but in the worst case, think about how the incrementally build the number up. Think about how you would incrementally build it. I mean, the idea of being able to reverse the number definitely makes sense. I mean, my best guess for getting that depth value would be to... Oh, crap, man. Yeah, the reversing thing makes the most sense to me at the moment. Think about how you incrementally build the number up. So, we need to build the number up from... I mean, I guess it kind of makes it more difficult maybe, but to do a string and then just to parse the string. You have 3. You do times 10 plus val. Yeah, but then in that case, that I'm not sure how that works for the 5, because it's the idea of how much by 10, like what power of 10 we need to multiply it that doesn't really make sense. Because looking at it this way, for example, here we need to multiply this 3 times 10 for this case, but here for this case we need to multiply it by 100, which is the part that's confusing to me. Here, let's try, you get 3 as a param. Wait a minute, hold on. So we pass the sum along. Oh, okay, that makes sense. Okay, yeah. Okay, so what you're saying is we take the current sum and we pass it into the method. Then in the method we do cur_sum times 10 plus node.val. Keep forgetting I added this chicken command. That's like a portion of hello world in the chicken language, which is probably my favorite language of all time. Very interesting, very, okay, so here, let's do past sum then. And what we're gonna do is if node is equal to null, we're gonna return 0, that's fine. Life's going pretty good, aside from the fact that it's been a month and I'm still waiting for Google. I got a response back to my inquiry. They said they still have no updates on team matching me. So it's not that I haven't been team matched for Google, it's they haven't even started. Okay. So cur node val is going to be equal to past sum. How can I join you in the code room, bro? Yeah, up there, exclamation point room, exclamation point link. Either one of those will give you the link to join the room. Past sum times 10. These mind-blowing moments are the best moments about puzzles. Yeah, it's like, it doesn't make sense for a while until it does. And then once it clicks, I think honestly that's probably one of the main reasons I've been so interested in CS. Because, what's it called? I don't even know how to explain it, like spending an hour or 2 on a solution and then you finally get it to work is probably one of the best feelings. And I don't know how to explain it like outside of CS. Hey, Incline Scorpio, thanks for the follow, man. I really appreciate it. To Windows, honestly, I'm kind of at the edge of this whole extension thing. Like, if Google doesn't get back to me soon, it's like I can't even consider them. I don't know how they expect you to be able to consider them when when they take so long. There's no way you can go to like a major company. It's like, hey, you know, can I get a 2-month extension while Google figures out how to match me to a team? So it's like you either, and the thing is, you're never even guaranteed. Like, okay, you made it past the final interview, but you might still not get team matched. So you're never guaranteed to actually have a job after. Okay. Let's do cur node val right here. Oh man. Okay. Cur node val. And I think how do we now? We need to check if it's a leaf node, right? So if root dot left equals null and root dot right equals null. Yeah. Why are you popping? So wait. Wait, this actually kind of hurts. Yeah, watch. It might just... I think the issue is... the issue might also be that he's doing a pre-order instead of a post-order. Actually, no, that shouldn't make a difference in this case, at least. Three two four 32415. Oh, are arrays passed by reference or passed by value? By reference. That's probably why. Pass by reference is always pop before return. Yeah, man, pass by reference has always been a big issue. Let's see. So you leave the stack the way that you got it. But then your children... Oh, I see what you mean. Move the pop down below second sum. Gonna make a deep copy. You do recursive calls, that would help. But making a deep copy of the array is already super inefficient. That might help. I hope it helps. Yeah, clean up after yourself. It's closer. Yeah, no, it's... I wonder if... I don't want to give away, like... that someone in chat helped me make. The fact that like times 10 plus val just makes the whole thing different. What do we have here? Same one. Okay. I guess for the time being we can go ahead and go over... Do you take interviews, Ro? I do not like host interviews. The thing that we do is like, you know, for our on-campus coding club, we are, what's it called? We decided to host a couple interviews as like a test run this Friday. So I think I have 2 people scheduled for half-hour sessions, but kind of not commercially or like for general purposes. So yeah, unfortunately, my job is to help you prepare for interviews with these streams as best as I can. And I know there are services that will offer you mock interviews. I just don't have the link to them and I can't remember them, but I'm sure if you Google like mock interviews, I know there's some paid ones and I know there's some free ones. You can also probably join, let me see, I think this Discord probably has, there's like a couple CS, yeah, Praps for mocks, that's what it was, thank you. Along with DS Algo, what else would you suggest for a guy with 1.5 years of experience? Oh man, if we're talking 1.5 years experience in industry, you're already 1.5 years ahead of me, because I have absolutely no, I mean, aside from my internship, I don't have any, any job experience. But honestly, I think the thing, if we're talking outside of DS and Alex, would be probably work on explaining your thinking. Because, like, for example, these streams have made it to where when I'm working on the problem, I don't even focus on explaining my thought process. I just kind of say things, and it's become almost second nature for me to verbally explain my problems, and I think that's helped me a lot. Because when working on the problem, I don't have to focus, okay, am I doing a good job explaining? Am I not doing a good job explaining? I just, I explain the problem. If I make a mistake, I'll, laugh at it, joke about it with the interviewer, continue on, and it's made it a lot easier, I think, in that regard. So that'd be my best tip. Let me see if I can find the server that I know for a fact hosted mock interviews. Is it not this one? Thought it was that one. I guess it's not that one. Yeah, if I can find it, I'll share it. So I've never personally used their services for mock interviews, and I, again, not an endorsement, not any sort of supporting thing. I've only been in the server to discuss like job offers and interview questions and whatnot, so I can't vouch for anything else that's on there, but I do know they do, I think, optionally provide mock interviews. For her power of 2 tasks, you don't need a loop, you can do constant time, but I only know it by accident and wouldn't be expected in an interview, I think. So, the power of 2 problem. How would you do this in constant time? That's very interesting. How would you do that? Here, let's go back to this first question, start off with this one, and move forward. I gotta go. Yeah, good luck. I have it in constant time. Really? Okay. I can just say I don't know of a hint that helps. So for this question, high frequency, all we really need to do is keep track of, what I did was keep track of how many times each number shows up in a hash map. Again, I will reiterate the fact that hash maps are probably one of my favorite data structures and one of my most useful ones. If you don't know how to solve a problem, throw a hash map at it. More often than not, it'll be some sort of solution. Might not be the fastest, but very often it'll provide you with a solution. So what I do is I make the map, and I keep track of a variable max. What this allows me to do is, instead of iterating through everything and then putting all the numbers in the map, and afterwards iterating through the map to find the max occurrence, I do it all at the same time, saving me another, I think at worst it would be O of n time. So even though the problem would still be run in O of n time, if I were to do it the other way, it would be slower. So what I do is at each number, I put it into the map, incrementing it by 1, and then I set max to be equal to the biggest value of itself or the value of the current one we just put in. And the reason that this is kind of super fast, and the reason that, again, maps are efficient, is because O of 1 get and O of 1 put. So adding to a map is O of 1 time, and adding to and getting from a map is O of 1 time, because hashing functions are great. Very difficult to come up with a good one, though, if you're doing it yourself. So yeah, this one I can say, I think pretty confidently runs in O of n space, O of n time, and O of n space. I don't know if there's a way to do it faster. I can't think of one, at least. Moving on to the second one, there was one solution I did where I brute force checked every single possible power of 2. Because in a integer representation there's only 32 bits, I think it's 32 bits at least, we can check every single power of 2, which is only 32 of them, not terribly inefficient. But the other way to do it is using bit manipulation. Because using a bitwise AND with a 1 will allow you to check whether the last bit is a 0. Yeah, that is constant time too. If there's like a faster constant time, it'd be pretty cool, but I can't think of what that would be. So what we do is we check to see if the last bit of n is equal to 1. If it is, we add up the number of 1s we've found. And then we bit shift n to the right by 1 to shift it over, well, 1 bit to the right. What this allows us to do is continue doing this until, yep, n minus 1 equals 0. So is that just replacing, let's say I were to just grab this condition from here, I think this would just do the exact same thing, really. Yeah, there you go. Wait, is this just the whole solution to the problem? I thought this was like a loop condition. Wait a minute. Is that just the whole solution? No, wait, no way, no way, hold on. Let me try that. Okay, here's what we're gonna do. We're gonna comment out this, and we're going to return. Hey, Visual, thanks for stopping by. Good to see you, showing up as a first-time viewer. Okay. How... Alright, let's go ahead and add them. The new friends. Semicolon. Anyone know complexity of math.log2 in JS? Bad types. I think it's just a missing parenthesis here. Am I doing it wrong? I think it might be flipped. Slow constant time, I don't know. Yeah. I guess the idea of this solution makes sense in the way that like it works up here. But yeah, this one I don't think I'd be comfortable like even knowing this to pull it out at an interview because I would have trouble explaining it. Okay. So yeah, this one still don't understand that, but a return number that is integer math.log2n. Oh, that's clever as well, yeah. Because what you're doing is, if it's log-based, logarithms are like inverse exponents from what I remember. So by taking the logarithm, if there's anything as a remainder, if it's like 2 point whatever, that means it was not a power of 2. But if it was a power of 2, you would get a integer that would be, I think, the exponent that you bring down. Haven't done logarithms in a good while. That is a very, very clever solution, though. So length of longest balanced subsequence. This was one that initially I was going to use a stack for, but you know, it was a good kind of realization to realize since you only have one type of parenthesis, you don't actually need a stack. So what we do is we keep an integer to see the amount of open parentheses we currently have. We then want to also keep track of the length of our current subsequence. What we do is for each character, if it's an open parenthesis, we add it to the quote-unquote stack as another open parenthesis that we're looking for a match to. Then, what we do is to say, if it's a closing parentheses, if there's something to close on the stack, meaning there's at least one open parenthesis, we can subtract it and increment the length by 2. And the reason that we increment the length by 2 is because our stack could look like this, and then we find this parenthesis here. This parenthesis goes and closes off itself along with that, making the length 2. So we need to increment it by 2. And we keep doing that until we get to the end, pretty much finding a matching closing parenthesis to an open parenthesis. And the reason that we can do this and skip things, and the reason that the position of it doesn't matter, is because we're not working with a substring, we're working with a subsequence, meaning we're able to skip over things. So for example here, find an open one, we close this off, increment length by 2. We find a closing one, we don't have anything on the stack, we ignore it. We find an open, open, close. Here, yeah, this one is, I guess, a good example. I'm trying to find a good example, but yeah, maybe not because log is so much smaller than the n. Honestly, I'm not sure. I think floating log 2n equals That's a good question. It's one of those things where you can really only do that, I think, in JS without because your variables aren't strictly typed to integers. But I think you could probably do something similar in Java with I guess a way to test that would be to test like the highest power of 2 take its logarithm in like the console. Hold on, let me try that. Hold on. So let me pull up a programming calculator. So it'd be 2 to the power of 31. 2 to the 31st power. No, I need a scientific calculator. Give me my scientific calculator. That's it as the power of 2. Yeah, so 2 to the power of 31 would be this monstrosity of a number. So here's what we can do. We can, yeah, could not find sort. Yeah, they just need to clean up their console. Let's see. Number dot is integer. Actually, not is integer. What we need to do is to say math.log2 of this number. Yeah, it looks to be a instruction that counts 1 in numbers. That would work too. Honestly, I'm not sure about the whole like floating point issues. That would be something to, I guess, just explore more really. Okay, and let's look at this last one. This last one is pretty clever. So the reason that I initially wanted to do this one in like a garbage way with like strings and utilizing global variables, but I got made fun of for that, so we decided to avoid using global variables as a whole for this problem. So what we do is we have a traverse method where we pass in the sum of the nodes above it, and we pass in the node we're currently working with. This right here, this little bit, I think, is what makes the magic happen. Because without this, I don't think I could have gotten this problem to work this way. It's a very clever realization that by multiplying the previous sum by 10 and adding the current value, we can sort of shift the number over one dot. Nah, it's okay. It's deserved. Global variables, I think, are something you should avoid if possible. They just don't look very good, and I don't think in like a professional setting it would be encouraged. I think they'd much rather. Granted, from what I've heard, recursion as a whole in production is just like best avoided, so it wouldn't really matter. But yeah, this allows you to shift the number over to the left by 1 and allows you to insert the new number. So what we do is we find the value of the current node by shifting it over by 1, like by 1 power of 10, and then adding a value to it. Then we traverse left and right, passing in this current node value. And we pretty much keep doing this, keep passing that value down until we hit a leaf node. So on the condition that we hit a leaf node, we want to pass up the current node value. So for example, here it'd be 3. We go down, we multiply 3 by 10, we get 30, we add 2. So we're at 32. We go down here, we multiply 32 by 10, getting 320, and then 4. On this condition, we have a leaf node, so we pass back up 324. Here, we'd, let's say at this node, pass up 321. At this node, going back up, now we see that it's no longer a leaf node, so we want to pass up the sum of the left and right subtrees, which from this node we're passing up 324, from this node we're passing up 321. So we sum them here, and we utilize the same pattern at every level to sum up pretty much either the left and right paths or the actual values when we hit the leaf nodes. Overall, I think this runs in O of n time with O of 1 space. As far as I can tell, it'd be O of 1 space because we're not really doing much. I think global variable's fine if that prevents multiple heap segment creation deletion, isn't it? That's a good point. I mean, I guess if your global my only concern with global variables like that would be like a security threat. but I'm not sure how that would really work out. But I think it's just better syntax, maybe? I don't know. Because, I mean, if you are, let's say, making like a deep copy of an array at every single layer of your recursive call, I think in that case, do what's easiest to read and understand. What you do is you take this, you link to the Stack Overflow article you inevitably stole it from, and you go from there. You let them explain it. It's interesting how, I mean, I've heard people talking about how they've had professors who'd said that, you know, like, Stack Overflow is for people who don't know how to do anything, and, like, to, you know, to, like, avoid Stack Overflow like it's some sort of, like, wildfire. But I feel like that's kind of the wrong mentality for it, because, I mean, you're never expected to, like, oh, yeah, I remember how to do this one specific thing from, like, years and years ago. But in CP, we generally talk about preventing things. Yeah, no, I've been a lot more conscious about memory, kind of usage and memory allocation going through the OS class, but I think it depends on the situation, honestly. If you have to have some sort of super complex recursive call, yeah. Because I honestly, like, going through legacy code bases, especially like at my internship, they are a startup, but they do have a very large already preset code base. And I honestly, I was like, yeah, they're like, yeah, we just need you to like write mock test cases for like these functions for the beginning. And I was like, okay, cool. And I spent 2 days digging through that legacy code trying to figure out what was happening and what was going on, because to correctly mock the functionality of certain functions, you need to understand what they do. And I was going through, and there was a lot of comments that looked just like this from other developers left behind. And it was pretty funny because I had no idea what it was. I realized the developers who are getting paid full-time also don't have any clue what it was. So overall, it was pretty funny. I don't even use horrible complexity, but if it's simpler, it's also easier to implement without bugs and then check in the interview. Let's start. And I think I'm gonna be heading out here for the day. I've got more paperwork to do, more homework to do. I've got an assignment that we had 3 weeks to do that I haven't started yet, and it's due Sunday. It's a fairly large C assignment with multi-threading producers and consumers, so I probably need to get started on that sometime soon. But yeah, I hope that this was somewhat interesting. It was good to find this question, especially. Quite like it. Very good for the mock interviews tomorrow. But yeah, if a global state is tricky, we saw when debugging past list references earlier. Exactly. Anything that's passed by reference in recursion can get very, very messy very quickly. But yeah, didn't understand 3 solution. Yeah, let me go ahead and I guess I'll run through it one more time. So hey Visual, thanks for the follow. I really appreciate it. So what we're doing here, right? An important thing to know is that we're working not with substrings, but subsequences. What this means is that the longest subsequence can be something like this, where we have 1, 2, we have 1 there, something like this, and then like this. The longest balanced subsequence in this case could be 1, 2, 3, 4, and then 5, 6. So we're looking for a subsequence where we can skip characters to find a balanced one. The stack keeps track of the amount of open parentheses we currently have to match. So let me write this out. Keep track of open parenth we have to match. And length is just the overall length of our subsequence. So what we do is we check every character in the array. So we check against every character. If it is an open parenthesis, what we do is we just add it to the stack as another one that we potentially can find a match for later on. It doesn't matter if there's like 5 other open ones. Yeah, CMX, thanks for stopping by, I really appreciate it. So yeah, here we pretty much just add as many open ones as we can to then potentially find matches for them later. So we can say, if it's open, we can find a closing for it later. Then, that's where we increment the stack. Otherwise, if it's not an open parenthesis in this case, it means, because there's only open and closed parentheses in our strings, means we found a closing one. So if this is a closing parenthesis and we have a open one to potentially close, meaning that somewhere prior to it there was a open parenthesis that didn't have a match. We're going to remove that open parenthesis. I think that's how you spell it. And then the reason that the length goes up by 2 is because, keep in mind, we just found a match, meaning that there was a closed parenthesis that now has, there was an open parenthesis that now has a closed parenthesis. And they match each other, which means the length goes up by 2, because we just found 2 matching parentheses, I guess. So 1 open plus 1 close equals match. And we keep doing this until we eventually get through all of them and we return the overall length. I hope that kind of cleared that up. It's a bit more difficult to explain than I guess was expecting it to be. But yeah, that's going to be, I think, it for me for today. I hope everyone enjoyed it. I won't be live tomorrow. Got to run those. Yeah, for sure. I'm happy to explain it. Happy to try and clarify it as much as I can. And I'm going to be running those mocks tomorrow. I hope they go well. I mean, I've never been in the shoes of an interviewer, only the interviewee. So I'll try and update it on Monday. Yeah, cool, Mew, for sure. I think it would have been really cool if from the start I had like archived all my solutions and started like either a blog or like a, I don't know, whatever else there's, like a paste bin with all these solutions just to see how they grew over time. But I think that's a bit of an oversight on my part. Yeah. Thank you everybody who stopped by. Thank you everyone who joined, who helped out, and for participating in chat. That's gonna be it for me today. I tried with a YouTube channel, but I could not upload my VODs. It was like I needed to be verified or something, and I never figured out how to properly upload my VODs there. It would have been nice though. I would have had like 80 hours worth of content. Maybe one day. Or, you know, if I stay on Twitch, eventually all my VODs will be past, what, like 2 weeks old, will be removed, and I will disappear from the internet. And then eventually come back when I end up looking for a new job. Alright, take care everyone. I'll see you all Monday.